Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Tonight's topic is component testing. We're sticking with this component testing theme we've been going on the last few weeks. And it is electronic throttle control. This is part 1 of 2. So this week will be part 1. Next week will be part 2. And to start this off, let's start off with this phrase. I think you've probably heard this phrase before. Yeah, just step on the gas, right? Step on the gas. Pedal on the right, step on the gas. But really, are we stepping on the gas? What do you call this pedal over here on the right-hand side? What is that pedal on the right? Is it the gas pedal, accelerator pedal, throttle pedal? I've heard it called any of those things, and I bet you probably have too. But when you think about that term, step on the gas, we're not really stepping on the gas, right? What are we doing? Well, if we think back to manual throttle control, which has been most of the lives of cars way back from the early days all the way through not that long ago, really, if you think about it. Manual throttle control, you have a physical connection between the pedal and the throttle. So this is my throttle plate, and then generally, you have that cable, and the cable will pull on a cam, and that will open the throttle, right? So I step on the throttle, pulls the cable, opens the cam, opens the throttle. So I'm not really stepping on the gas, I'm stepping on the throttle. Or if you want to think about it this way, we're stepping on the air. Right? Step on the air. I'm opening an air valve to allow more air in. As we think back to the carburetor days, vehicle still works on the same basic principle, right? So this is a basic carburetor. So we have the air cleaner up here. You want to have nice filtered air, of course. Choke valve, fuel comes in over here. So we got the bowl, and then we have the float. When the float gets high enough, it blocks off the fuel flow so it doesn't overflow. But then when the fuel flow gets too low, then it opens up this valve, and in comes more fuel. And we also have this little passage here that's called the jet, right? If you're thinking, taking some of you back to the olden days here, I haven't changed the jets, but that's a thing. And then when I step on the throttle pedal, or the accelerator pedal, if you will, it's going to open this throttle plate. By the vacuum of the engine, it's going to draw more air in, right? So that you have a volume of air coming in through the top. And then when it hits this venturi here, well, the venturi is a smaller area, so it speeds up, right? It speeds up the airflow going into the engine, creates a small little itty bitty bit of vacuum over here, enough to suck the fuel out, atomize it, and spray it in over the throttle plate, right? Then it goes in, mixes in with the air, goes into the combustion chamber, and so on and so forth. You know the rest. But really, we're stepping on the throttle, right? We're stepping on the air. It's how one of my teachers explained it. And that just always kind of stuck with me when you're thinking about throttle. You're not really stepping on that gas, you're stepping on that air, right? So after carburetors, we graduated, right? We came to electronic throttle control, and it started maybe with the throttle body injection, you may remember from back in the day. And there was the throttle body. And in those days, in that case, it was a single injector, and it took the place of the venturi and all that. And it just sprayed the fuel directly in the throttle plate. But we use a very similar system all the way up through nowadays on a car. So if we think about it, we got a throttle cable connection over here. That's where my cable would hook up. And it's a little cam. and it has a metal rod that goes through all the way through. In here, of course, we have the butterfly, the throttle plate. And then over here on the other end, we have this throttle position sensor, because now that we don't have, it's not really, it's kind of like a half mechanical, half electronic control, since the computer is controlling the injector, either the throttle body injector or past that, the port injectors. We have multi-port fuel injection. It needed to know where that throttle plate is in space. It doesn't know where it's at unless you tell it. So we have this throttle position sensor, which is a potentiometer. So this goes on the end of that rod, and then depending on where that rod is in space, that will that'll show us, right? So if we were to break that down in this wonderful animation that I drew here, I am not the best. I'll tell you, I'm not the best, but we have this. It's a potentiometer, right? And we have this outer ring that is it's like a film, right? So it's got a variable resistance, and depending on where this wiping arm, it wipes across that, slowly rides on it, and as it goes, the voltage will change. The voltage output coming out the middle here will change. So I have 5 volts in, I have ground on the other side, and depending on where the resistance is, depends on how much voltage I get out. So if I were to sweep it back and forth, it sweeps back and forth from minimum to maximum. Then my voltage output changes. So if I were to look at that on a scope, so I have voltage coming in now, usually on most of these systems, when it's off or idling, right, at minimum throttle input, you're going to see not 0 volts. You will not see 0. You don't want to see 0 volts. That's what I'm trying to say. Key on, you should see maybe half a volt, 0.4 of a volt. Usually what you see out there. It's a low voltage, usually half or less. Then when we go up, it'll sweep up. When we get to maximum, it'll level off. Whatever the maximum happens to be for that particular design. In this case, we're looking at about 4.5. You could also see maybe 5 volts, right? It just really depends on how the manufacturer designed it, right? So what you do want to see is a nice smooth sweep up. You don't want to see any breaks in the line, any noise, any weird dropouts, right? So that is let's say a good one, right? And then when that's sweeping it open, then we sweep it back closed, we should see it go down nice and smoothly on the backside as well, right? Because if it's good going up, theoretically it should be good going down. Now, what if I had a problem? Common problem with these, especially back in the day. I think they've addressed it with some different designs now, but especially early models. What if I had, this is a highway driving car, and I go and I drive 2 hours each way to work every day, let's say, right? And then during that time, I'm doing about 65, 70 miles an hour. To keep that throttle steady, well, that throttle plate is going to be pretty steady, and that throttle position sensor in turn will be pretty steady. Now, it might move a little bit, but it's not going to move a lot. And over time, remember I said that's like a film or a coating, that's going to wear off in that spot where it's getting a lot of wear. So let's say right here, we have a little bit of a hiccup, right? It's still making an electrical connection perhaps, but there's not enough coating there, or not enough to make a contact with this wiping arm. So if it goes up, oops, I have a dropout, right? So it comes up and then it drops out real quick, but then it goes right back. So you may have heard of a flat spot on a throttle position sensor. This is what we'd be looking for, a place where it drops out. Now, it doesn't always drop out, depending on how the failure is. Could be going down, could be, I've seen it otherwise going up as well. We have a high spike right there. So maybe the resistance is less, so it goes up, right? So there can be a difference, but we don't want to see a broken line. That's bad. And then we sweep it back down. Since it's going to go past that spot again, we're going to see it again on the backside. Now, of course, this time it's a little bit shorter because we went down faster than we went to open, right? So we can see that in the pattern, right? So that is an example of a battle. Now, keep all this in mind because we use very similar systems nowadays, even. But nowadays, we've put a lot more middlemen in there, so to speak. So instead of having the direct connection between my throttle and my throttle plate, I now have a PCM and a bunch of wiring and a couple sensors too. So if we look at this, this box over here is going to represent our accelerator pedal position sensor. Remember how I said not the greatest artist in the world, but you'll get the gist. So accelerator pedal position sensor there, throttle motor assemblies. We have throttle motor, and then we also have throttle position sensors in there, and that's attached to, of course, the throttle plate right there. So when we step on the throttle, sends a signal to PCM. PCM makes calculations based on load and speed and all of that. And then it sends out a signal to the throttle plate to open it however much it's programmed to do so, right? Now, coming back out of this, I didn't draw it, but coming back out of this, we do, of course, have feedback back to the PCM in the way of the throttle position sensor, right? So the throttle position sensor relays back to the PCM and says, hey, here's where the throttle is at. But if you think about it, since we don't have a physical connection anymore, we're talking about an input and an output. Right? My input and my output used to just all be right there on the throttle body because I have my throttle sensor as my input back to the computer, and then my output's throttle, right? But that's over the cable. In this way, we have it replaced with a computer. So inputs going in, outputs, of course, going out of the computer, and then it does have an input coming back from the TPS. So we think about cruise control. On a drive-by-wire car with electronic throttle control, when the PCM's in cruise control, it really doesn't care where this accelerator pedal is. Right now, it's going to obviously watch it. So in case I do need to step on that pedal, then I can accelerate if I need to. But for all intents and purposes, when I set it in cruise control, I'm not putting my foot, I'm not leaving my foot on the pedal. I'm going to maybe rest it on the ground nearby, but I'm not going to be holding it on the pedal. So it won't really need an input. It controls the output, the throttle plate, independently of anything else, just based on engine load. So it says, okay, driver, you told me you want it to be this speed, so we're going to keep it this speed, regardless of where the accelerator is, because I'm going to be able to control that myself. Now, if we think back, I don't know if you've ever driven one of the cars with maybe earlier versions of cruise control. I know my wife has an older car that has a cable cruise control. So it's a cable throttle. And then next to that throttle cable is another cable that goes in a little box electronically controlled. And all that does is open and close the throttle. Now, on those cars, you still have the mechanical attachment to the throttle pedal. So you could, if you just rested your foot on the throttle pedal and it needed to accelerate up a hill under cruise control, you can feel that throttle pedal go down because it's still turning the throttle and you're physically connected. But of course, with this type of vehicle, electronic throttle control, you would not have that. Now, another thing we need to think about with electronic throttle control is we need to have a backup for our sensors. So generally, as a rule, I haven't really seen any that don't, but usually you're going to have two sensors. You're going to have two accelerator pedal position sensors and two throttle position sensors. Just in case one fails, you can still drive the car and it won't just completely die on you on the road. Now, if both fail, usually as a safety precaution, we just shut the throttle and the car stops running. We'll talk more about that in a minute, but generally you're going to see that. So this is a taken apart sensor. So you see we got the two little wipering arms there, and those go on these pairs of, there's my film, right? The resistive film. So since we have this, it kind of also creates a wear item, as you can see there, and we'll talk about how they address that in a second. But if I wanted to look at the wiring diagram on an example of one of these, this is on a Toyota Camry. We have the accelerator pedal sensor. So we have 3 and 3. So each sensor, or each on the pedal, it has two independent sensors. So we got sensor 1, this is these 3, and then sensor 2. So it has power, ground, and a signal return back to the computer. We can see how all of it is supplied by the computer. 5-volt power is from the computer, ground is from the computer, and the signal wire goes back. Then if we want to look at the output side, throttle body, so we have the motor itself. This is a positive and negative. We'll talk a lot more about that in the next episode, so to say, or next week. We'll talk a lot about the motor and the throttle position sensors. But the throttle position sensors work in a very similar way too, where we got power and ground. In this case, we have some, it is a magnetic Hall effect sensors, right? So it's a little bit different in the way it operates. And that's the newer design that offers us no real wear items. So that's a little bit better of a performance there. So, but that's how it's wired. So we have six connectors there, and then 6 connectors there. Now, if we think about electronic throttle control, it's just a couple of components, right? We have the throttle pedal, which is going to have my connector on the top, and then it's going to have whatever sensor type is in there, either the traditional potentiometer, which is with the film, or it's going to have magnetic Hall effect in there as well. And then on this side, if we look at the throttle body, if you've seen a modern throttle body, it's got this big old thing on the side with the 6 connectors, and that contains the stepper motor to gear drive, and also the throttle position sensors in there as well. And as I said, we'll get more into detail on that part of the equation next week. This week's mainly on the input side, right? So if we look at this throttle accelerator pedal position sensor, here's how it's wired. So it's 6 through 1. So sensor signal, ground, 5 volt, signal, ground, 5 volt, right? So as we said, it's got power, it's got ground, and it's got a signal. So that gives us test points or things that we can test, right? We can test for 5 volts, we can test for ground, and we can test for signal coming out. If I were to do a test on this, a voltage test in this example, so this is on a Subaru. All right, so we got our 6 pins there we just looked at, and it says key on, engine running, key on, engine off, and engine running. Should be about 1 volt to about 3.7 volts on both. So in this case, these sensors output the same voltage at the same time. On other designs or other manufacturers deciding on what they need to do, there's a voltage difference from one to the other, and that's a check that it uses. But if I were to check this out, go down here, we got 0.68, 0.65 volts. And then over here, we got 3 volts at the max on this particular one. So it goes down, goes up. Nice, smooth. You can see how they mirror each other. Now they're separated. If they were together, it'd be exactly identical or pretty darn close to identical because the voltages are supposed to be the same. All right, so we can see the difference there. They're offset a little bit in this picture with that. But what if I had a bad one? That is a possibility, right? At least one of them could be bad. We could have a bad contact in there. So here's an example of some bad connection in there. It's bad contact. Goes up when it gets towards the top. We get all this noise. It drops out to 0 a couple times. You got some real good dropouts and glitchiness, but only in one. And that is totally possible to happen. That's why we have 2. In case one fails, the other one hopefully doesn't fail at the same time, right? So that could be a problem, but we want to see, do I have a dropout? Do I have a glitch? Right? In this case, there's some glitches there, so that would indicate an issue with that sensor. And then we talked about how we have the potentiometer type, and then we also have this Hall effect type. So this is a cross section of a Toyota Hall effect type. So it has the magnets on the outside, and it has these sensors on the inside. And based on where that magnetic field is in space, as it turns, as it rotates, it outputs different voltages back to the computer. So that's how the computer knows. And in that case, since we're dealing with magnetic fields, we don't have any contact, right? So I'm not wiping off that film in any way. I'm just have the contact, no contact. So you're really only moving parts of the bearings that are inside there. And then on this design, it also has the 2 sensors. So we have an offset in between the 2 sensors as well. So we see 0.8 volts at the bottom, and then 3.75 volts at the top for number 1, 1.6 volts at the bottom, 4.55 volts at the top. So we can see how they kind of parallel each other up as it goes from full off to full on. So let's do a little bit more research and go live on the tool and talk more about some of that information. All right, so I got my Zeus here, and I have my 2016 Toyota Camry, which is what we were just looking at there. 3.5 liter engine, pretty common vehicle, right? So a code that could set on an accelerator pedal sensor. It's a P2122. It's just easy to remember, right? 2122. Nice and easy. So we can look up the information, right? So we have my regular results here, my experience-based results over here. So I'll plug in there. And we have specs and testing, and these are all the categories of information we have for this particular accelerator pedal position sensor. So I'm going to go into OEM testing first. So if I want to test it, I want to learn more about how I'm going to test this P2122. I go in here and it says, let's see. Oh, this electronic throttle control system does not use a throttle cable. Go figure, right? So these DTCs relate to the accelerator pedal position sensor. It's built into the accelerator pedal sensor assembly is 2 sensor circuits. They call it VPA, which is the main, and VPA2, which is the sub. Sensor is a non-contact type sensor and uses Hall effect elements in order to yield accurate signals even in extreme driving conditions, such as high speeds as well as very low speeds. The voltage which is applied to terminals VPA and VPA2 of the ECM varies between 0.5 volt and 4.75 volts in proportion to the operating angle of the accelerator pedal. Signal from VPA indicates the actual accelerator pedal opening angle and is used for engine control. A signal from VPA2 conveys the status of the circuit and is used to check the accelerator pedal position sensor itself. So in this case, one isn't, it's not really a check on, it's a check on the sensor, right? So they're not duplicating each other. One is here's the signal I'm sending to the computer to tell it where to put the throttle. The other one is to say, hey, it's working, and here's where we're at in relation to each other, and they can check voltages across. So the ECM monitors the actual opening angle through the signals and controls the throttle actuator according to these signals. So there's that figure we just looked at. And then if we have a code, it gives us our different DTC detection criteria, high voltage, low voltage, whatever it happens to be. These are the codes that would apply to the pedal position sensor. In this case, it says, hey, well, let's use a scan tool. We can also use a scan tool to check the data as well. So we want to see what it is fully released versus fully depressed. That'll give us a high and a low, but it doesn't really tell us what's going on in between, right, using that scanner data. So that's why we would also want to look at the scope data. Go down here a little bit more. It tells us the monitor description. If I go down a little bit further, there's talks about malfunctions. So malfunction thresholds, confirmation driving pattern. I might have gone too far. Oh, wait, no. Okay. So talking about fail-safe. Right, so when these are set, it enters a fail-safe mode. If either circuit malfunctions, so this is kind of important. So how does my car performing? If either circuit malfunctions, the ECM limits the engine output. So it may still run. It's just going to run at a low power, or maybe can't get it over a couple grand RPM. If both the circuits malfunction, the ECM regards the accelerator pedal as being released, and as a result, throttle valve will be closed and the engine will die. So you'll know it if they both die, then the engine won't run. All right, fail-safe mode continues until it passes and the engine switch is turned off. All right, and then that just shows us a circuit wiring diagram from Toyota. And then here's how to check it with the scan tool, right? So good information on how that works. Now, if I wanted to look at the wiring diagrams, it's going to pull up my factory wiring diagram, and then I can also look at my accelerator pedal position sensor wiring diagram down here on my 3.5 liter. We'll just jump down to that in a second. Depends on your internet speed, of course. There we go. Go to engine. And there we go. So there's my accelerator pedal position sensor right there. Zoom in a little bit if I want. Notice that it's pre-highlighted, so I can dim these other wires, make it easier to see. And there's my diagram, just like we said. So we got our six wires there, 1 and 2, and then there's where they go to the computer, and there's the color codes, and there's the positions on the terminals, all right there. Great, so now I know where it is. Obviously, we know where the pedal is, right? But now I know what wires do what on the sensor. So now I can go over here, and I've learned a little bit more about it. So now I can go into my guided component test. Now, if you have a snap-on tool with guided component tests, it makes it a lot easier to test things because it's all VIN-specific information. So over 5 million available tests in here. Tests many different systems on the vehicle. In this case, engine is where the throttle control lives, right? So throttle control system. And then I could check the motor, I could check the accelerator, check the throttle position sensor. I'm going to check the accelerator, right? So if I want to learn component information, I want to learn about how this operates. It's going to tell me how it works. So it looks like about 0.5 volt to 5 volts, as we said before. It's going to show us the connector view here, tell us what the wire colors are, and tells us how the accelerator pedal position sensor works. We already mentioned that. So we can go over and do a DC voltage test, for example, and it'll have you test it, each individual signal, right? So signal number 1 is going to be pin 6. I'll back probe at pin 6. And then if I hit view meter, click, click, buzz, buzz, there we go. And then I see about 0.5 volt, and then we could sweep it up and down. This is just a simulator, right? But we can just sweep it up and down, back and forth, and watch for any dropouts or glitches in the wire, right? Let's see, go up and down, depending on how hard you depress that throttle pedal. Go up and down smoothly or not, right? So you can just measure the known good voltages, 0.5 to 1.1, up to 2.5 to 4.5 is where we want to be, from close to open. And then on the bottom, on the other one, with 1.2 to 2 volts to 3.5, 3.4 to 5 volts, right? So it gives you the specs. It sets up the voltage range where it needs to be. It sets up the time base where it needs to be. So really, I got to plug it in and I can test it going back and forth. So you'll be able to see that signal. Now, I don't want to see any sort of glitches, right? We don't want to see any glitches in the wire. It's hard to do with 2 hands, right? So you can see how we'd have some glitches there. That would be bad. That's a higher voltage. Then if we wanted to open, it goes to ground, we could have a glitch like that. Right, so we don't want to see any of that. Now, more often than not, it's going to be quicker than my hands move, but you get the drift, right? You don't want to see any breaks in that line, right? You want to see a nice smooth line up and down just like that. Now, having learned all this, we'll be able to apply it again when we talk next week more about how this interacts with the rest of the throttle assembly, and also how our throttle position sensors will be very much the same as this accelerator pedal position sensor when we get to that next week. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.